Yes, hello everyone. I'm very happy that you're here. So I will present you our master's degree course that is entitled Economics and Technologies for Sustainability. Very differently from the course that you just heard, this master's degree course is a master's degree in economics, so far away from natural sciences in terms of the masters that you get. Very close, though, in terms of the topics, because this master's degree carries the title Economics and Technologies for Sustainability, because we will teach you both the economic part connected to sustainability implementation and the basis of the technologies for sustainability implementation. The course, although being a master's degree in economics, is located at the DSAT, which is a Department of Natural Sciences, which already shows you that this course is really a hybrid construct. We have in total 6 departments that are contributing with their professors and with their research areas to this master's degree course. Half of them are economic departments, half of them are natural sciences departments. This course is brand new. We started just in the last October, so we are currently doing the first year. We are in the middle of the activation of the second year, like all the other courses. And we are looking forward to our international students, because this is one of the new international study courses that the University of Milano-Bicocca offers. The course is centered around sustainability, and the obvious question is, why do you need a course centered around sustainability? You've heard in the previous presentation by Professor D'Arienzo that also the material science guys have obviously the aspect of sustainability when they talk about sustainability as sustainable materials, etc. In our chemistry degree course, we have a sustainability aspect. The point in the new course that we launched in October is that we want to treat sustainability in a very holistic way. That is why we need economics and natural sciences, and then not only material sciences, not only chemistry, not only biology, not only geology. We will teach you the whole bunch of it in the necessary details in order to make you a very new professional figure that we call sustainability specialist, that I will outline later on. So the motivation is, as I said, that we need to approach sustainability in essentially all the various areas of our daily life in all countries around the globe. That is why we did it as an international course. So you know that sustainability is often related to via these famous 17 goals, let's say, the global goals of sustainability that the United Nations generated as a very iconic, by now I would say, a very iconic picture of sustainability. If you look in detail at it, the situation is not as easy or not as straightforward as these tiles might show you, right? What it means is that in order to make it happen, we need sustainable resource management, we need sustainable production technologies, we have sustainable energy aspects. We need sustainability fostering business management and business planning, right? We need to be able to measure and quantify sustainability. So we need indicators, we need novel ways to describe how sustainable a company is, for example, by using certain types of resources rather than other types of resources. We need to work on societies in order to become sustainable. That goes everything from the energy complex of cities in order to city planning. Where do I put the roads? How do I put connectivities, public transport, etc.? And obviously, last but for sure not least, we need to communicate sustainability. So we also, as the faculty where we have the course, we think that it is also important that you know how to communicate sustainability in the end, because you have maybe the chance to study this course, other courses. So anyway, you are among the highest educated people in your societies if you study at universities. So you are in a privileged position, and we think that you need to know how to use this privileged position in order to create awareness, right? To communicate to people that didn't have the chance to study what sustainability means, how you implement sustainability. You need to tell them that it is eventually complicated, but maybe also in little details, not at all complicated. to implement sustainability. And that is another aspect that is closely related to these 17 sustainability goals. Now, why? We're still not doing the why, right? I'm still doing the how. Think of water. Water is a resource. You all know that. And depending on the country where you're coming from, you might know that water is a very scarce resource. Now, we have a lot of water on the planet, but we do not have a lot of drinking water on the planet, right? So water exists in different forms. Water is also something that we need in industry in order to cool reactors. Now, if you think of an energy plant, they have cooling systems. So water is good for a lot of aspects. So water is a resource, and we need to protect this resource, and we need to manage this resource. If you live in a country where it doesn't rain a lot, where you have deserts, etc., you know much more about water management than we might do in Europe, for example, on a practical level, right? But globally, we all need to learn how to deal with resources that might be more or less abundant. So we can see water as an example for resources that have to be managed, and we will tell you how to manage these resources. If you think of water as a resource, that is just one thing. We have other resources, right? If you know a little bit of chemistry, the picture that you see now is very familiar to you. The picture that I show you is nothing else but the periodic table, where we have listed all the elements that exist on Earth. You see that some of them are green, some of them are yellow, orange, and some of them are red colored. The red color means that the natural resources for these elements are running out. So in the last let's say decades, right? 100 years, 150 years, we use a lot of these resources because we understood how to get them, where to find them, how to manipulate them in order to make, for example, the materials that you've heard in the previous talk, right? If we do that, now we're just humans, we see that something works, we continue doing it because it works fine, it makes our life easier. Now we can harvest energy, we can eventually use the energy, etc. So we're doing what humans do. We are continuing something that is pretty well working. If we do that, however, we might have in the very near future a problem because we are consuming the resources that this planet provides. And so far, we do not have anything else but this planet. So what we need to learn is how many resources do we have? Where are they? And are they going to end? And if they are going to end, what do I do? Right? And the obvious question, maybe some of you already know, is that we need to recycle. So another part of this course is also to show you recycling. Because if we want to have a digitalization, for example, that we need in order to advance, not only advance technologically, but to advance in our efforts to become more sustainability on a planetary level, we need digitalization because the problems have reached a dimension that the human brain alone, without the help of a computer, will not manage. So if we would run out of the elements, for example, that are needed to construct computers, other electronic devices that will help us in a digitalized world in order to be more sustainable, we need to recycle them. We need to find them. Finding them is an interesting aspect, right? Because obviously, the computers that have already been built, the cell phones that we do not use anymore because they broke or we buy a new model, they are becoming novel resources for some of these elements. So we need to learn how to valorize novel resources. We have to identify novel resources, for example. These novel resources can be seen as something that is called nowadays novel entities. So whatever we produce in mass quantities as humans in our technologies generally, but also the plastics, also the stupid things like plastic bottles, etc., polymers, synthetic polymers that are around everywhere. We can see these things as novel entities. Novel entities means they are novel resources, not maybe natural resources, but they become resources. We manage to produce them in such quantities that their presence on this planet can be seen as a novel resource. So we need to teach you how to use these novel resources, and we need to teach you how to identify these novel resources, right? So that means these novel resources are basically our current waste. In a couple of years, or it's already started this transformation, our current waste will become a resource for the future, and you need to know to identify this new resource and to valorize it, obviously, right? To take it, to harvest it, and to valorize it in order to substitute the ending fossil, traditional, or natural resources with the novel ones, in order to enter in a very big loop of recycling, if you can imagine what I mean. All this has to be done in the context, and I already said that the context is our planet. So that's why we can talk about planetary boundaries, right? And if you think of our planet as the boundaries, these world maps are showing you basically what we have in order to use, apart from the novel entities, now the natural resources, etc. Problem always, the landmass is the same landmass, the oceans are always the same oceans. So if you just have a quick look at the following slides. So this is a map where you see where we have arid areas, more tropical areas where it rains, etc. The greener it is, or the more rain there is, and the better the vegetation grows, for example. That is important because if there is vegetation that grows, we could use the vegetation as a renewable feedstock, biomass. No, growing biomass is a renewable feedstock. That's a resource for the future eventually. Not everywhere in the world we can have this opportunity to use these novel resources, because if you live in, if you take the desert areas, there is no biomass growing in the desert areas, right? If you think of the same aspects, so you need rain, you need good soil in order to grow crops, which would, for example, relate to the zero hunger sustainability game of the United Nations. We can think of areas where we can harvest maybe more than once a year. So we can do a double or triple cropping. And if you see where we can do a double and triple cropping, those are the same areas where we have a very nice possibility to grow quickly biomass. So we run into conflicts, right? We need to decide whether we use the land for growing crops to eat, or we use it for having biomass growing that we use as resources for creating then chemicals, for example, or fuels, etc., or whether we want to have these areas to grow biomass that helps us in our battle against climate change, because we need the natural forests, because there's nothing else on Earth that fights CO2 levels as a natural forest. Now, so same areas. If you look at this map, same areas. This is the area where the soil is good. So these are really the areas where I want to grow crops, where I could grow really well crops so that they have high yields of the edible part, etc. Unfortunately, it's the same areas where we find minerals. So the question is, do I want to take the mineral, sacrifice the forest on top, or do I want to have the forest and I do not take the minerals out of the ground? Or do I work on novel technologies, novel chemistries, novel approaches in general in order to harvest minerals, in order not to destroy the nature on top, right, on the surface? If I have to dig a mine, normally that's not very compatible with a nice natural forest growing on the surface still. Okay, so we need to have novel technologies for resource harvesting, and that is an important point. All this obviously requires energies, which brings us automatically to the energy sector, right? I need to make sustainable energy plans for my sustainable mining activities, for example. So you see that everything is very interconnected. And last but not least, it's connected to this. What you see here is a biodiversity heat map. You know that biodiversity, some of you might have heard the term biodiversity. Biodiversity, or we understand more and more, basically every year, that biodiversity is very, very closely connected to our well-being as humans on this planet. So what would be needed is to protect the biodiversity and to avoid that the decline that we have in biodiversity since the 50s, 60s, where we started really to industrialize in big parts of the world, is progressing, because otherwise we run into a deep issue, right? So, and if you look at the interesting places, right, it's always the same places on our planet where we have all the resources, where the crops grow, where the natural forests grow, where we have the biodiversity. And if you a little bit think about it, it's not surprising at all that it is always the same areas, right? That makes it really challenging to look at the single aspects that we need in order to maintain standards of living, increase standards of living, fighting global challenges like climate change, etc., while using the resources that we have on a planetary level. Because as I said, despite the last efforts, etc., to go in space, etc., our planet will be for the next hundreds of years our planet, and that's the resources, right? So we need to learn to deal with them in a much better way than we do currently. Now, this is another picture that some of you might have seen. So whatever you think of, whatever aspect that I just mentioned, and other aspects that go beyond this, whatever you think of, everything is, unfortunately, as you know, very much interconnected. Unfortunately, in the sense that it makes it very complicated to find solutions, right? It's a real challenge. But it's all connected to sustainability, and we need this long-term sustainable development. So in order to bring you in a head position, in order to tackle the modern problems and to eventually implement in your communities, cities, companies, wherever you find yourself, sustainability, because we need to work on every level on sustainability, we have thought of this course. So in this course, we will try, or we hope to teach you how to realize sustainability, how to implement sustainability, measure sustainability, because obviously, right, if I implement sustainability, I somehow have to quantify its progress or its success, how to guarantee future sustainability. So we try to make you a sustainability specialist. This sustainability specialist is a person that is not an economics guy, that is not a scientist, a hardcore scientist, but it's someone that can communicate, be it with the management level, so understanding basic economic concepts, and a person that can talk to the, let's say, more technical part, to the engineers, to the chemists, to the production people, right? So you are in the middle. If you think of a company context, like this figure tries to suggest, you're in the middle, okay? You're the central person that makes sustainability happen in the company, being able to connect logically, intellectually to all the worlds that are within a company, okay? Now, this sustainability specialist can exist in a more economic fashion, in a fashion that is more focusing on resources and production contexts, or in a fashion that is focusing on a renewable energy context. And so we have courses that you can see as three main pillars that will teach you aspects within the economics part. So you're a sustainability specialist more towards the economics part of sustainability. So a sustainability description in terms of economic key figures in companies, indicators of sustainability, ESG aspects, etc. We can have you as you can choose courses to become a sustainability specialist for the resource and production areas. So you learn how to manage resources, what are novel resources, how to manage the non-renewable resources, how to implement renewable resources, how to produce sustainable materials in the sense that they are recyclable, following the concept, for example, green by design, that they are compatible with health standards, which are currently always changing, etc. Or you become the third different figure that we can offer. It's a figure that is more focusing on green energy aspects. So you will learn different energy technologies, different ways to harvest energies, obviously sustainable energies. You will learn, however, also how conventional energies work, because it's green, guys. It's not always sustainable, right? And if I'm sustainable, I might not be green. The question is always in the certain, context wise, do I want to be green? Is it better to be sustainable? Do I have a chance to be now sustainable and then later, with a little bit more time, I become also green, etc. Right? So especially in the energy sector, that is a very, very tricky question sometimes. So you will learn all the basis for the different energy types in order to then understand how to make an energy plan, for example, for a company, for a city. Okay, so a person that is more focusing on energy. We have obviously 2 years. We have some standard courses which are for the economic figures. We have standard courses for the production and resource people. We have other courses for the energy context, obviously, right? If you have access to the slides, you can look at the names of the courses by yourself. We have obviously together with those specialized courses, we have courses which are maybe useful for all of the three figures, depending where you see yourself in the future context. Do you want to work for a company? Do you want to work for public administration? Do you want to work as a freelancer? Do you want to work in an NGO, for example, right? So we have different courses that accompany the mandatory courses and other courses free of choice, or that you can choose from to become one of the professional figures. And to round up basically your personal idea of you being a sustainability specialist. Where do you see yourself in the future? What do you think you need in order to be the most perfect sustainability specialist in your context where you want to find yourself after having studied? Some courses are obligatory, some courses you can choose from. We have lots of choices. You're basically very free to design your personal sustainability specialist figure. Obviously, there will be professors, right, myself and lots of other professors that will give you a hand, right? We will discuss, we will guide you to your choices if they are not, to make sure that you are not missing an important part or that you are not going too single-sided, right? Because the idea was, as you remember, we want to teach you holistically what sustainability is about. So we will guide you a little bit, but I promise you that you have really a lot of choices. We are international as an international course. I go ahead a little bit faster. So we are international. So that means we teach everything obviously in English. We have a very innovative didactic concept. So you will have lots of hands-on laboratory courses. We have lots of interactive ways to do the teaching. We want you to work. We need you to work because obviously this course is multidisciplinary, transdisciplinary, and interdisciplinary. So we know that you come from different backgrounds and your fellow students will probably have a different background than yourself. So you all find yourself merged in this master's degree course. You have to work together. We will make you working together so that you learn the view of a natural science person, for example. If someone, for example, studied natural environmental sciences in the bachelor's degree, and that person has then to work together with someone that studied a more typical bachelor of economics, for example. Right, so we will make you work together so that you learn the perspective of the other people, of the other person that you are talking to, in order to open up your mind to see problems from the other perspectives, etc. Okay, so that is obviously better if you do peer-to-peer learning, if you do flipped classrooms, all these modern didactic concepts that help you to get a hands-on experience as much as possible. It takes 2 years, 120 credits. Obviously, we have it planned in a way that we do each semester 30 credits in order to be compatible with other European courses, because we want you also to go on Erasmus. For example, you could go on Erasmus. We have lots of destinations across Europe. You could do your thesis everywhere in the world if you like. That is, so we planned it to be absolutely compatible. So you have the maximum freedom within the European framework to study, for example, a semester in Spain, or if you like to go to the north, you can go to Sweden, do some biorefinery, for example, in Sweden, or you do some LCA analysis in Spain, if you like it, etc., etc. So you have a lot of flexibility. As I said, we designed it in order to be very compatible. We are new, but I'm already, together with my colleagues, we are already working at the first revision, because we are part, or the Bicocca is part of the European University Alliance Invest, and we try to get this course to be part of Invest. So I'm heavily working on having a double degree with the university in France. That will be, however, from 28 onwards. So for some of you, it might be okay. For some of you, it might take too long, but I promise you that even without being officially a double degree, you have lots of possibilities to spend a semester in one of our partner universities, and we have very good connection to any of the universities that you see on the slide, for example, and to lots of other universities via the different professors that have their personal connections, right? So you have really a lot of possibilities to move within Europe in order to broaden as much your possibilities to study. With this, I think I have finished the presentation. So if you have any questions, obviously now here, or you send an email to one of the 2 email addresses that you see. Thank you very much.